Hello, everyone. Thank you for joining. Well, this is our third meetup, and we will be focusing on topics related to IoT, especially AWS IoT. Today, we have Mario, who will be talking about edge computing and like how do we build the edge computing platform to support the industrial IoT initiative. Over to you, Mario.
Thank you, everyone, to join. Good morning, afternoon, and some people around Europe and in Asia. So my name is Mario, and I work as an engineer at Vopak. I don't know. Does anyone here knows who is Vopak or what Vopak does? Let's see if the camera's on. I see some people nodding. So for the people, for the people that they don't know what is Vopak, Vopak is the leading independent storage bulk liquid company. So we store everything that is critical for life that is in the liquid state. Okay, it could be oil and gas, could be the liquid that is in your battery of your car. It could be the paint that is used to paint your house, everything. So Vopak is probably I think it is the oldest Dutch company in the world. It's 405 years old. It's currently located in 23 countries around the world, 66 terminals, market of 6.2 billion, and we have around 5,000 employees. One of our biggest KPIs is safety at work. Like because sometimes in the end of the day, some people need to go safe to work, right, and to home. So and sometimes there are accidents in our terminals. So it's one of our biggest KPIs. This is the locations of our terminals. The green dots are the terminals, industrial terminals. Red dots are hubs and terminals. So the bigger industrial terminals that we have. Every terminal is located around specific routes, trading routes. So we serve as a middle in the man in the supply chain of the liquids products. Vopak on the IT side is going through a massive digital transformation. Vopak is becoming a data-driven organization where edge computing is one of the pillars to get the data from the industrial domain. Okay, so we have all these industrial sensors. So during this digital transformation, Vopak noticed that we don't only store liquid. We store a lot of data. We have a lot of sensors, around 25,000 sensors, 30,000 sensors per terminal. And these data was totally isolated. Okay, we are not getting any of these data, and now we are getting it. In the meanwhile, we on this digital transformation, we are building Internet of Things. We are doing digital twins. We are doing 3D modeling. So we are building our terminals on 3D. We have cybersecurity programs because you don't want to be hacked. You don't want to be the next colonial pipeline. We are using glasses, smart glasses to visualize our terminals and using HR. So, okay. So what you now ask is, what is edge computing? Okay. It's a very new phrase. Okay. And in Vopak, edge computing is an enabler. Okay, so what it does is that we have these data in silos, unknown data, and what we do, we collect this data. This data is what we call dark data. So it's in silos. We don't know what is the data. We only see numbers. We don't understand what is the data. Is this a unit of measure? What is the meaning of over this data? And what we do at the edge, we give some context. So we grab the data that we don't understand, and we put it some meaning over the data. So we do like data processing. It's like doing an ETL on the edge. Okay. So we grab the data, we give some meaning over the data, we store the data locally, we filter some of the data because probably you don't want to send all the data to the cloud. And then we send a data to the cloud where, okay, you can understand the data. Okay, this is a temperature, this is coming from a flow meter. Okay, the tank is settled, the flow rate is below an average. You can do then, okay, this data can then be utilized to create your machine learning models, to train your machine learning models, and other cases. At Volpac, we have some use cases, okay? We have, for example, pipeline monitoring, okay? You want to see if there is a leak in the pipeline. We do asset performance optimization, which we call SNAP, which we click and we can suggest to the operator. So the people on site, hey, do this because this will make your asset perform better. We do energy monitoring and optimization. You can search. We have a post in Forbes.com where we do peak shaving. So we have assets that are running 24/7, and we are warming up them 24/7. And because of global warming situations, and yeah, we need to reduce our footprint, we need to shut down these assets, right? And we can, through this data and through machine learning, we can understand, okay, when is this asset going to be used? So we can then, okay, tell the operator, hey, this asset is probably not going to be used in the next 12 hours, and it only takes 2 hours to warm up. Can you please shut down it? And then the operator can say yes or no. Because we have then trucks that arrive to our tanks to and pump into the tanks or pump out to from the tanks, we need to optimize the trade of so how to where the truck goes, which truck is the fast one, how should be done. So we can give all this data and it can be optimized. We have way bridges which measure, we have license plates so we can see which truck is the fast one, the weight of the truck, which product it is inside, how much time it took to collect the product. Then the requirements in Volpac, okay? So you say, okay, we have this edge computing, we have these use cases, but where does it fit in our enterprise architecture? What are the requirements? So we had 4 bullets, and these 4 bullets were to move away from industrial connection protocols to a standard IP-based communication protocol. So if you work with industrial communications protocols, you're gonna see that most of them are still running in Modbus or even older Profinet technology. So they are very old technology compared to what we have nowadays on IT, right? Then we had a situation, we don't want all the data and we want the meaning of the data. And we don't want to have dependencies because this data was there, but we didn't have access to it because there were independent silos between companies, right? So you have Emerson, you have Yokogawa, you have ABB, you have Honeywell, and all these companies have this data on their site isolated and you are dependent of them, okay? So, okay, we need to aggregate all the data from all sensors at the edge. We need to process it, aggregate it, filter it, and then send it to the cloud. And this needs to enable analytics in real time or near real time. We need to give another bullet. We need to give as much information to the asset as possible to be used in different systems, ERPs, mass systems, machine learning, big data analytics. So everything needs to have the most information as possible. So, and the last point and bullet was we need to aggregate all the data from all the terminals and send it to one cloud place, store it in one place. So in order to every application to go there and access to it. So, and this, we reached this architecture. Okay, you can say, oh, looks very simple, and this is just an ETL. But bear in mind, there are firewalls in here. I did this very simple draw in order to not complicate this after in the recording of this. uh, um, so there are firewalls between every segment of this, right? So we have the cloud, we have the terminal, and then we have the terminal automation. Terminal automation does not, majority of the cases do not belong to Volpack, okay? It belongs to ABB, it belongs to Yokogawa, Emerson. We don't have access to it. What we ask to the provider is, hey, give me the tag IDs, so the identifications of your asset and the IP of your OPCOA server. So probably now you are saying, hey, I'm looking at this architecture. This is site-wise edge. You build site-wise edge, right? I'm going to explain. And bear in mind, this was built before site-wise edge or site-wise even. We start building is in 2018, in the end of 2018. So we were pioneering all this architecture. So what we do is very simple. We have a Greengrass. I don't know if people already know what is Greengrass. Let me see if people shake his head. I see one person shaking. So, so what Greengrass does? Greengrass, I call it, in my opinion, my bias, like it's like a container orchestration platform, okay, locally. So allows you to run AWS services locally on site. So offline too, right? So what we have a Lambda, AWS Lambda, running OPCOA client that connects to OPCOA server. It does the subscription session, and then it collects the data, all the changes. We have we collect on change, and we have cyclically pooling. Okay, so we pool every sync 1 second, and we give on, we get on change too. Then Greengrass as a local MQTT broker, we send to MQTT broker. We have then processing Lambda, which is the Lambda that gives context to the data that we are collecting. And then we have a Lambda that stores in the local MongoDB. And probably now you're asking why local MongoDB, why not InfluxDB? Main reason was because in-house it's one of our principal already storage. In this case, MongoDB Atlas. So we use the principle to reuse. Okay, so it for us will scale faster. So then we have a local API where, for example, because our terminals are located very far away from population due to safety and securities, the internet is not so good. Okay, so we need to have local API and local data, which is only stored for 1 month locally, but it's used in case the internet goes offline. Which can happen. We have places where when a boat comes or a tram comes, we lose the internet. So that's one of the use cases for having local storage and an API. Then we send this data after being processed to the cloud. We have exactly the same Lambda storing in the MongoDB Atlas. Then we have a Fargate, and then on the Fargate we have an API which we expose to our internal applications and data science teams and BI teams for them. Okay, you can say, oh, and there is some infrastructure workaround, right? For example, we have Ansible that deploys our Greengrass. We use a system manager to deploy our Ansible roles, our Greengrass. And the reason is this, because we have a proxy in the middle, and OTA does not work with the proxy. So we need to do that. That's documented on the AWS website. All our infrastructure in the cloud is automated using CDK and CloudFormation. Everything is done through CI/CD. We have load testing, unit testing, stress testing, regression testing for this. So how we collect it? This is the raw data. raw data that we get. Okay, this is this value. It's very, you look at this and I was like, oh, what I'm looking, right? You don't know. So we need to give some context, some information. By the way, one very important thing on these data is the source timestamp. Okay, it's very important. You need to have the source timestamp in order to understand if there is any latency or if you're looking at the really data, good data. Sorry. Then this is how we enrich the data. Just an example, a video. As you can see, it's very fast. This is already in the cloud. In this case, we are using a Botlek, which is in the Netherlands, and we are collecting data from multiple sites at the same time. So this is how we store it in the end of the day. When you go to our API, you're gonna see, okay, we have multiple timestamps, which allow us to trace when there are latency issues or we lose data. We have messages IDs, we have the source system. Then on the data field, we have then the device type, the tech type. Okay, how are we looking at the temperature, a tank, a weight bridget, a valve, a pump, a location. Okay, is this from Americas, from this terminal? The unit of measure, because you know, some countries are using Fahrenheit, other use Celsius. Um, we have then measurement method and type. For example, in a tank level, you can measure if this is like looking at the glass, right? You measure if the glass is half empty or half full. This is very important because when you show that on an ARP or something like that, you want to see, okay, we are pumping in, and you look, no, we are pumping out, you know, because you need to understand what you are measuring, if you are measuring the free space or the occupation space. And these changes, all terminals are different. They use different measurements. So we need to specify this information to the application side. So if we look at what we have right now, I just changed these values because I was just looking before this meeting. We are currently hitting 25 million events per day. We collect operational data and events and alarms. For example, if a pump stops working or is too busy or if there is a leakage, we collect that information too. So we are going to 25 million. We are currently in 15 terminals in 8 different countries. We have currently stored 3 billion records, more than 3 billion records from the cloud, from the sensor. So when we collect the data from the sensor to the cloud, it takes less than a second. Our team is very small. I say here 16 members, but we have a Scrum Master. We have from these 6 members, you need to remove the Scrum Master. You need to remove the product owner. You need to remove the solutions architect. So right now okay. We have three engineers in our team. And that's how we build the product. And 3 engineers for 8 countries around the world, 50 terminals, and we expect to the end of 2022, we are live in at least in 48 terminals. That's our goal. So you can imagine you double these. So 15 terminals. If you are 84 terminals, you need to triple the value of these events and records. Okay, and the size of the team will still stay the same. So we automated a lot in order to facilitate our lives. Yeah, challenge in building these type of solutions. Very much we built. If it was today, probably we would go for something like Sitewise Edge, off the shelf, very easy to deploy, to configure. Everything can be infrastructure as code. Is keeping all teams in sync. So we are collecting as to multiple systems, as I was telling. You need to keep network security in sync, the security operations team in sync, the terminal people, the electrical engineers in sync. And this is because then it's multiple countries. It's you have a cultural barriers to the way I interact could be different as a person in the United States or in China. and time zones, right? I send an email now, I know I'll only get the response the next day from China or from the United States. Getting the correct data. So at the beginning, we were just collecting all the data. We don't care, just give us the data. And there was a lot of data that was not needed for our services, okay? I think something that you need to understand is which data do you need for your use cases and requirements. And I can tell you that getting the raw data and which data it needs, it's probably one of the hard things to do besides the sync of the all teams. You can get you need to, the more data, the better, does not apply here. So you need the smarter data to take the smarter decisions. So the better data. Um, data content, giving context to the data, it's very hard because some people, you can say to some systems that the data is calculated on the system, so you don't get the current value but the process value, okay, and the measurements, and then getting all this information takes around, it depends on the site, but around 4 weeks, 5 to 5 weeks, getting all the data, everyone in sync. Building for scale with a small team. So if you look at teams that are processing, or companies that are processing 25 million events per day in multiple locations, you're going to see that their team is huge. And we are only 3 engineers, right? Very good engineers. I think one of them is here. So hooray and kudos. So it's a very hard job to keep doing it. So the more we scale, the harder it will be, right? On call, you have on call situations, you have scalability issues. You need to automate first, sync automation first, right? If you are building to scale. If you are only in one factory, do it manually, gather the data. Data fixing, for example, if you change your schema, you need to change the schema in all locations, right? So you need to automate how you're going to change the schema in all the data and the previous data, right? When you have 3 billion records and you want to change the schema of the 3 billion records, you need to find a better way to do it without affecting your API. Some of the issues that you can have, right? What next? For us, now that we are gathering the data and becoming a data-driven company, so people are saying, "Oh, we can do this. Oh, we can do this. Then we can do this." So we need to empower and give more options, right? We want to run analytics at the edge, right? Right now we do it at the cloud, but you can do it at the edge. It's just another Lambda. People say, "Oh, analytics at the edge," or a machine learning at the edge. And you can run machine learning as an inference. So it's just another AWS Lambda that you deploy. And Greengrass scales very well, right? Greengrass runs your Amazon Echo with Greengrass inside. So we can spin up, I don't know, we did a load testing, and in our case, we reached 25 Lambdas running at the same time in a small server. Evaluate Greengrass version 2. So we are still running on version 1. Version 2, we need to change a lot of things in our side because our application, our deployment strategy, we need to change a lot of things, and it was site-wise edge. For these, we might need to change our data model structure and our data structure. Yeah, data structure is probably the most important. We're already starting doing 3D modeling, proof of concepts majority. So our goal is to enable even more and more analytics case, grabbing more data and smarter data. Yeah, that's it. Thank you. Yeah, feel free to make questions.
Yeah, we have a few questions.
Mario.
Yes.
If I may ask a question. You're using edge devices, right?
Yes.
is that like Raspberry Pi devices, or you have some more muscle on that side?
Yeah, more muscle, big servers right now. The reason is because our to put a Raspberry Pi in our case, because our hazards systems, it needs to be ATEX certified.
Oh, okay.
And yeah, and not a lot of device gateways are ATEX certified, right?
Yeah. So it's the electricity norm that makes sure that no sparks and no
Yeah.
open.
Yeah. We have even more certifications. Right now, it's the first one that comes to my mind. Yeah.
It's important, obviously, when you're working with flammable liquids. What happens if one of these edge hosts goes offline? I assume it's a grid of servers, but suppose that would go offline in any way. What would happen in that case?
Okay, right now, let me say. So this is virtualized servers, right? So if this goes offline, one server, it means that a lot of servers went offline. So it means that the terminal probably stopped. No trucks are able to arrive, or and bear in mind that then we have DCSs, right? I didn't share on the picture. It means that the DCS is offline too. But in case that only the IT part that goes down, right? We with our automation using Ansible and if the internet is still working, we already did a test. In 50 minutes, we can redeploy everything, even less. Probably 10 minutes, we can redeploy everything, all the databases, everything. So in 10 minutes, everything is up and running again. And then if the internet goes down, we are able to repull the missing data again, right? And reprocess the data, because Greengrass stores it has a buffering / caching mechanism, Greengrass. For our case, the amount it depends of your the size of your memory RAM of your server. But in our case, we can store around almost 1 hour of data in the cache. So it means when the internet goes up again, we are able to reprocess all the data without even needing to go to the database. Yeah.
Thanks for this explanation, Mario.
Yeah.
Okay, so we saw that you're using MongoDB, right?
Yeah.
So ultimately, you'll not be able to, use the AWS IoT to DynamoDB connections and all. So how do you do those things?
So all the data, first thing first, it goes to MongoDB Atlas, right? And for example, in Atlas, we can use data lake from Amazon, from MongoDB, right? Which is under the hood is an S3 bucket. We are not using DynamoDB, yes, correct, or TimeStream. For example, TimeStream, when we built this application, TimeStream was not there. We didn't have TimeStream. Was still in beta or early access, right? So DynamoDB we did, but the problem of DynamoDB is that you pay per reading and per inserting, and the amount of what we insert and the speed, and then and internally we are at internal modelment of MongoDB, right? And MongoDB Atlas and data lake, and if we need to put this data somewhere else, we can do data pipelines with this to the data science. So everyone fetch the data from the student from our API running in Fargate. If anyone needs any data, they go to Fargate API running there. Then in the DPI, I didn't put any example here. In DPI, they can get historical data from previous year, between years, and between days, between months, from one specific sensor or all sensors, or one type of measurement or all measurements. So they can, whatever they want data, they can collect it from the API, which it's a challenge because of indexing. Knowing, okay, what are the most index people are gonna use, but that's based on our monitoring system, right? In our case, we have New Relic and CloudWatch. where we monitoring which calls people do. And based on these calls, we fine tune our indexes. And so we are a little bit more proactive. We can see, oh, there is this delay on the API calls, or they are now putting these API calls. Okay, let's build the index just for this. Yeah.
And are you using the MongoDB as on the edge as well?
Yes, yes. If I go back, so in local storage, I have local MongoDB. This is orchestrated using Cloud Manager. So Cloud Manager is like an orchestrator from MongoDB that does the installation, it does system updates, it does everything for you. Yeah, we don't need to do anything. We install an agent through Ansible, and it does everything for us. We don't need to care about anything else. Backups, monitoring, logging, it does everything for us. It's like having as a SaaS, but on site. So it facilitates our team work. I don't need to hire a DBA for these type of things.
Okay, thank you.
Mario, are you considering using 5G maybe with or without edge in the future for these type of sensors?
Yes, yes, we are SIM cards, and we have an innovation department. Okay, so we have a department where they do. If I go back, Edge started from the innovation department. Okay, so we have an innovation department that is already looking at use cases of using 5G for some of our things internally, from augmented reality, because we have simple tablets running applications on 5G, and VR. I think is robots. We want to automate even more our operations. So yes, 5G is in our scope.
Okay, cool.
Okay.
Hey,
so,
Mario, just wanted to say.
Yes.
Yeah, Mario, hi. I just want to say hi. This is Sean over here. So we work together for this project. So
yeah.
Great presentation. Thanks.
Just to be aware, I didn't mention here because I didn't know if I had time. First, one thing first, the Atlas MongoDB is hosted in AWS, as you see. And the second thing is that we worked very close with Amazon. Okay, I was going to put here is if you are building something to scale and involve Amazon from the beginning, day one, involve Amazon. Because the main thing is that one, you can, if you have, you can sign NDA, and then nice information before building whatsoever. So you can think about the future, okay, what you are building. You can have good feedback if you are building something right. And for example, right now we are building things, prototyping. Amazon have a prototype team, and we are building prototypes with Amazon side by side. Look like Volkswagen did with Amazon, right? We are not the size of Volkswagen, but it's similar. Yeah.
Yeah, I think that's gonna be the statement of the day, bold statement of the day.
Yeah. I'm speaking. I have my accountant here in the meeting. Hi, Peter.
Guys, if you wish, we can just pause. I mean, cut.
No, it's fine. It's fine. It's fine. No, because there are decisions here that when I'm talking here, and there are decisions that we took. Most of the times are based on internal architectures, our enterprise architecture. We couldn't jump to DynamoDB at first, right? We need to reuse our internal acknowledgement, because first it's a very small team, agile team. That is the most important thing that you need to think, right? And we need to move fast. And the learning curve, okay, if we already have MongoDB, let's use it. And in the future, let's think about other things, right? For example, now we have site-wise edge, right? We maybe just move to site-wise edge. That's the thing, right? If people hearing this talk are in the company, industrial company, looking how to build now edge solutions to enable your industry 4.0 initiatives, I will advise to check out site-wise edge. I think it will do a big heavy work that operational technology people do now. Not only monitoring and alarms and events, it will do a heavy work, easy dashboards for you. Yeah, that's my feedback after 2 years, almost 3 years of building this platform. Yeah, for you guys. You can still build it if you want. The same thing.
Hi, Mario.
Yes.
Jean-Marie here.
Yeah.
Hope you're doing well. I have a question just at the end there. You mentioned Fargate as the cloud API solution. Any particular reason why you chose Fargate over other services?
Yeah, the reason is because we are reusing the same Docker image that we use on site. It's exactly the same code, the same API, the same Docker image. And first, it's faster to deploy. So we use CDK for this. So we built our CDK, our Fargate infrastructure, I think in 1 day. At the beginning, we started, for example, with Beanstalk because we were prototyping. But then we saw, okay, we need to deploy this locally, this API. That was one of the reasons. For example, going to Kubernetes, right? Will be for us overkill. If you say to me, okay, we have 10 APIs and Istio and NATS and okay, yes, but it's just an API with 4 routes. So we're looking at 5 routes. Yes, we have 5 routes. So not very over engineering complication. So yeah, that's why we went to Fargate. It's easy, simple, cost saving too. It's not very expensive, and we can reuse our Docker image. I hope that this answers your question. Yeah.
Yeah, thank you.